Online students, can you please confirm? Is my voice is loud and clear? Okay, done. Fine, guys. So let's start the session. So in the last class, let's have a brief things what we have discussed in the previous classes. First, we have seen what is meant by linear regression. And in the linear regression, we assume the data is linear between the input versus output variable, whether it is a simple linear regression or simple non-linear regression. Okay. If I take a simple linear regression, the equation is going to be y hat is equal to beta 1 x plus beta naught. And if you come with respect to simple non-linear regression, the equation is going to be y hat is equal to beta 1 x squared plus beta 2 x plus beta naught. This is the equation. So for degree of 2, degree is equal to 2. Y hat is equal to beta 1 x cube plus beta 2 x square plus beta 3 x plus beta naught. This is for degree of 3. This is also a simple non-linear regression. Simple means only one x variable is there. You are having only one x variable and one y variable. If you are having like this, then this is the one which we have discussed. In this, we have to identify whether this equation or whether this equation or whether this equation. Finally, we have to identify the coefficients and intercept values, which gives the minimum square of errors. Finally, we have to identify which gives the sum of the squares of errors as minimum. Whether it is a linear regression, whether it is a non-linear regression, the ultimate goal is to have the sum of the squares of errors should be minimum. We have to identify their coefficient or intercept values. Out of infinite values we are having, we have to identify proper your beta values such that the sum of the squares of error should be minimum. Whether it is a simple linear regression, whether it is a multiple linear regression, whether it is a multiple non-linear regression, the concept remains same. Okay. So if it is a linear regression, within a linear regression, we are having, within the linear regression, we are having simple linear regression, multiple linear regression. In simple linear regression, one x variable and one y variable fixed. Whereas in multiple linear regression, multiple input variables and but only one output variable. X1 will be multiple. X will be multiple. Okay, there is no limit on the X. So multiple input variables will be there. One output variable Y will be there. Then it is multiple linear regression. Similarly, within the non-linear also, we are having simple non-linear, multiple non-linear. In a simple non-linear, we are having again one X and one Y. We are going to create X square. This is created. Okay, created variable, created. So I'm writing here created. And we are going to apply the linear regression over that. Whereas if you go with the multiple non-linear regression, we are having X1, so on up to multiple input variables. Now what we are going to do, for each variable, we are going to create X1 square, X2 square, X3 square, so on up to Xn square. We are going to create these things. Square terms, cube terms, we are going to create. And we are applying the linear regression over that. Simply to say, non-linear regression is equal to, non-linear regression means nothing but polynomial regression. Polynomial regression is equal to increasing the degree, that is adding the polynomial features plus linear regression is called as polynomial regression. Polynomial regression means polynomial features with linear regression is called as polynomial regression. Just you are going to increase the degree and you are applying the linear regression over them, right? So these are the things which we have covered in the previous classes. Now, in this, most important point is for linear regression assumption model. It is an assumption model. So we have to check the assumptions. We have to check assumptions. If one assumption fail means all assumptions will fail. If one assumption is done means all the assumptions will be same. Okay. Mostly all the assumptions will be satisfied if one of the assumption is satisfied also. Otherwise, fails means all of them will fail. Now, if you clearly observe here, there we have to check very clearly that is called as variable significance. We have to clearly identify this, that is called as variable significance. Whether that particular variable is a significant variable or not significant variable. This is one of the most important in linear regression. If you come with the non-linear regression, here also we are applying the polynomial features and linear regression only. So here also we are going to do the same thing, that is variable significance. Whether this one or this one, wherever you are applying the linear regression, you have to check for the variables are significant or not. If the variables are not significant, you have to delete that particular variable. Wherever you are applying the linear regression, remember this. Wherever you are applying the linear regression, you have to check whether the variables are significant or not. If the variables are significant, then we have to continue with that variable. If the variables are not significant, we have to remove that particular variable, right? Now, coming to the today's class. In today's class, we are going to discuss next concept called as regularization. The most important of entire machine learning. Regularization. Regularization means which reduces the overfitting problem. One of the most important one. Regularization, which reduces the overfitting problem. It reduces the overfitting problem. Regularization reduces the overfitting problem. Now, let us understand what is overfitting problem and how it is going to reduce. And before understanding this topic, we have to understand two technical words. One word is called as bias. Second word is called as variance. Bias and variance. Okay, two technical words are there. One is called as bias and the second word is called as variance. And there is one of the most important interview question is called as explain the bias variance trade-off. Most important interview question. Okay. Now let us understand this bias variance trade-off. Yes. Let us understand the bias variance trade-off. Now let us take the first one called as word called as bias. Second word is called as variance. Right? So we are having bias and variance. Now, what is meant by bias and what is meant by variance? And if the bias is more or variance is more, if you are having a very high variance and low bias, then it is called as overfitting problem. High variance and low bias is called as overfitting. And low variance and high bias is called as underfitting. Model. Okay, high variance and low bias. Now, what is meant by low bias? Bias means nothing but train error. And variance means nothing but test error. Simple words. Bias means train error. Variance means nothing but test error in a simple words, right? Now, if a model is having low train error means what is the meaning? Error is low means what is the meaning? What is the meaning? Low train error. If any low train error is there, low bias. What is meant by low bias? Which is nothing but low train error. That is the meaning of this. Now, what is the meaning of low train error? Means high train accuracy. Accuracy is high. High train accuracy. You are having the accuracy, train accuracy very high. Now, similarly, high variance. What is the meaning of high variance? Means high variance is equal to high. What is meant by variance? I have told you, test error. Variance means test error. High test error. High test error meaning is nothing but low test accuracy. In terms of accuracy wise, if you speak, then it is called as low test accuracy. You are having test accuracy low, train accuracy high, means train accuracy is greater than test accuracy. Train accuracy is greater than test accuracy. Then it is called as overfitting problem. Then it is called as overfitting problem. And test accuracy is greater than train accuracy, then it is called as underfitting problem. Earlier I have told you using accuracies. Now I'm telling you based on the error wise. Okay. Now bias means simply train error. Variance means simple but test error. Simple words. Right. Now a good model should have low bias, low variance. A good model should have low bias, low variance. Means low test train error should be there. At the same time, low test error should be there. A model should have with respect to low train error, at the same time, low test error. Then it is called as a good model. Right? Bias means train error. Variance means test error. So let us see one example based on this. And how we are going to overcome this overfitting problem by using the regularization. That's we are going to see in the today's class. Let's see the concept one by one. Is that clear, guys? If required, you write. I will wait because one of the most important one. Most important one. Bias means train error. Variance means test error. Okay. So let me write in a notepad and I'm going to upload this notepad also in the drive. Just give me 1 minute. I'm opening the notepad. I will write here everything once again. So first one is bias. Bias means nothing but train error. Next, variance. What is meant by variance? Test error. Right? So if you are having bias, right? So bias and variance. Now, high variance. Now, what is the meaning of first low bias? Let's start with low bias. What is the meaning of low bias? What is the meaning of low bias? Just a minute, guys. Low bias. Low bias means equal to low train error. Low train error, which is also called as high train accuracy. High train accuracy. Next is called as low variance. Now, what is meant by low variance? Means low test error. Low test error, which is also called as high test accuracy. Next, high bias. Next meaning of high bias. What is the meaning of high bias? Means high test, not test, train. High train error. High train error. The meaning of high train error. What is the meaning of high train error? Means nothing but low train accuracy. Opposite to that. Accuracy is low, means error is more. Next, similarly, high variance. Now, high variance. What is the meaning of high variance? Means high test error. You are having the high test error. The meaning of high test error is also called as low test accuracy. That is the meaning. Okay. Now, for a particular model, for a particular model, for a good model, for a good model, for a good model, for a good model, good model means it should have a low bias and low variance. It should have a low bias and low variance. Then it is called as a good model. Means which is nothing but low test, which is nothing but equal to, which is nothing but equal to low bias. What is meant by low bias? Low train error, low train error, and low test error. It should have low train error and low test error. Both should be low. Both errors should be low. And error should be low means what is the meaning indirectly? Accuracy should be high. High train accuracy. We require the high train accuracy. And high test accuracy. High train accuracy and high test accuracy. That is the meaning of this. Any good model should consist of low train accuracy and high train accuracy and high test accuracy. Both of them should be high. Then it is called as a very good model, right? Now, for example, if you are having one of them high and one of them is low, then it is called as either overfitted or underfitted, right? Now, if you say that underfitted or overfitted, let us start with overfitted problem. Overfitting means it is you are trying to fit with respect to more amount of data, and it is learning more things, more things, and it is trying to by heart whatever the example you have given. It is trying to understand the example. It is not understanding the concept. It is trying to understand the example, and it is getting overfitted or by hearting. Overfitting, simple words, we can also say that by heart. It is just simply by hearting. Whatever the given data is there, just you are by hearting the data. How you are by hearting the given data? Example, you are fixing the example. Okay, for example, for explaining this concept, I'm going to show you one example. I'll explain using one example. I'll explain everything. In my mock interview, if I ask you something, you are explaining the same example to me only. You're not changing the example also. You are explaining as it is the same example to me. Then what it is called as overfitted. You can create multiple examples now. Why that example only? I have already explained with one example. You can't apply one different example. That example only you have to apply. You're understanding the concept, or you're understanding the example. That is with respect to overfitted. Means, for example, if I'm explaining for anything in the class feedback, something I'm explaining, in the interview, if I ask the question, means you will also say that, sir, in the class, if you collect the feedbacks from the student, means same example. Instead of that example, you can try with another example, right? Multiple examples are there, infinite number of examples are there in the world. Why you are taking the same example? Right? Now, overfitting means in terms of having the high variance. Having the high variance. Overfitted model is also called as high variance model. High variance and low bias. high variance, low bias. Now high variance means it is going to have the high test error. Test error will be very high. Test error. I require accuracy and not error. I require accuracy. But here it is having the high test error and low train error. Train error is very low. Means in the training it is understanding everything, but in the testing it is failing, which is nothing but equal to, your, in terms of accuracy wise, if I say, it is having high test error. What is the meaning of high test error? Means low test accuracy. It is nothing but low test accuracy and high train accuracy. It is having the high train accuracy, but it is having low test accuracy, which is called as overfitted problem. Training is done very well. On the train data, it is working very well. But on the test data, on the unknown data, on a new data, it is not performing well. Then it is called as overfitting problem. In the students or in the machine, the both of them, most of the cases will have the overfitting problem. In the students also, students will understand the examples, or they'll try to learn the notes, whatever the notes they have written, that one only they'll try to understand. Okay. In the class, how the students are going to do is the same way, the machine also will. Whatever the data you have shared, within the data, it will identify the pattern. It will forget that you are going to test on the new data, and for the new data also I have to work properly. It will not understand. Whatever the data you have shared, it is going to understand that one only. Within the given data only, it is going to understand. In the given data, if something wrong data is there also, for the wrong data, it will analyze. But whatever the given data, it in the given data only, right? So coming to the next one, last one is called as underfitting. So in the interview, if they ask you difference between underfitting versus overfitting, in the interview, remember, in the interview, most of the questions will be based on the difference. Most of the questions will be based on the difference. Not only my test, which is I'm conducting on Saturday. Apart from that, most of the interviews also will be on difference. Instead of asking what is overfitting, what is underfitting, instead of asking two different questions, if I ask what is the difference between underfitting and overfitting, in one question only, two things will be covered. Separately, why to ask two things separately? What is meant by supervised machine learning? What is meant by unsupervised machine learning? Instead of asking these two questions, I'll ask directly what is the difference between supervised versus unsupervised. What is the difference between regression versus classification? Obviously, regression, what is the difference means? First, you have to explain me what is regression, what is classification now. Means automatically that two questions are already included. What is regression, what is classification? Questions are already included in that. So that is the reason why in the interview, they'll ask most of the questions with respect to what is the difference. If the question, the interviewer has asked you, what is difference between overfitting and underfitting, means you can tell either by using the word of variance or bias, or by using the error, or by using the word of accuracy. For example, someone asked me what is overfitting means. I may say that low test accuracy and high train accuracy. Train accuracy is greater than the test accuracy. Then it is called as overfitting problem. I can explain like this. If someone asks you, explain the bias variance trade-off, then you have to use the word of bias and variance clearly. High variance model is called as overfitted problem. High variance is called as overfitted. High bias is called as underfitted. High bias with low variance is called as underfitted, just opposite to this. Okay. So here, don't get confused. Only two words are there, that two opposite words are there. Similar kind of in hypothesis testing, null and alternate hypothesis, and with respect to accept and reject. Reject is also called as accept is also called as do not reject. Similar way, two words are only there, that two opposite direction are there. Here high is there, low is there. Only two words which are opposite. Test is there, train is there. Both are opposite. Accuracy is there, error is there. Opposite. Just three words, a combination of three words, but in an opposite direction we are working. But if you observe clearly, only three words I'm discussing. One is called as low or test. Second one, low or high, test or train, accuracy or error. These are the three different words. right? Is that clear, guys? So underfitting problem, if they ask me, is explain with respect to accuracy wise. If they ask variance and bias variance trade-off, means explain with respect to high variance model is called as overfitting. High bias model is called as underfitting. Simple. Is that clear? Now, high bias. What is the meaning of high bias? What is the meaning of high bias? High bias means high train error. High train error. Both are same. Everything are same. Out of these three, anything is same only. Okay. Out of these three, anything is same only. Out of these three, anything is same only. One I'm saying in terms of error wise, one I'm saying based on the accuracy wise, which are opposite to each other. High train error and low test error. Okay. Which is also equal to low train error, low train accuracy, and high test accuracy. Simply to say high test accuracy means test accuracy is high, means test accuracy is greater than train accuracy. Test accuracy is greater than test accuracy. High means obviously that is more, right? High test accuracy means test accuracy is greater than train accuracy, then it is called as underfitted. And here which is high? Train accuracy is high. So train accuracy is greater than test accuracy. Train accuracy is greater than test accuracy is called as overfitted. Is that clear, guys? Done. A good model should consist of high test accuracy, high train accuracy, which is also mostly it is said to be train accuracy is equal to test accuracy. Both are equal. Then it is a good model. Train accuracy and test accuracy should be the same. Okay. Then it is a good model. Is that clear, guys? If anyone wants to take the screenshot or photos, take. If you have written miss, okay, good. But remember, in the interview, without the word of overfitted or underfitted, there is no interview. In the interview room, 100% they have to ask this question. If they're not asking what is meant by overfitted or underfitted, means they are not selecting for you as a data scientist. They are selecting for separate role. Any data scientist in his life, for any project, he has to face overfitted or underfitting. 100% he has to face. He has to face. There is no other option. And he has to reduce that. Now, solution. Coming to the solution. Next heading is solution for overfitted and underfitting. Solution for overfitting. First, let us start with overfitting. Solution for overfitting. Now, what is the solution for overfitting? Coming to the solution for overfitting is, the solution for overfitting is in terms of one, option number one is called as regularization. Is called as one of the solution. One is regularization. Two, solution. One more option we are having to reduce the overfitting. Okay, solution for overfitting. Second option is hyperparameter tuning. Hyperparameter tuning. You are going to tune the values and you are identifying which is the best value, neither having overfitted or underfitted. Identifying the best parameter, which is a neither overfitted or underfitted. Identify the best value, which doesn't have either overfitting or underfitting. Change the values, change the parameter values. One is regularization, one is hyperparameter tuning. Using these two, we are going to reduce the overfitting problem in machine learning for any project, right? So coming to the solution for underfitting. For good model, no need of solution. This is already good model. For good models, no need of solution, right? So now coming to the solution for underfitting problems. Underfitting, solution for underfitting. What is the solution for underfitting? Means solution, one and only solution we are having here. One solution only is there. The solution is collect, have more data for training. Have more data for training. Means train accuracy is low. Train accuracy is low means it is not able to understand properly. If it is not able to understand properly, try to give the more examples, means more data. For example, students are not able to understand in the class, underfitting, train only not proper, training only not proper. Then what is the solution for that? We have to give more examples. If that example is not clear, we have to try with one more example. That is not clear, one more example. That is not clear, one more example. Till the student gets the concept very clear, we have to give multiple examples. So just by giving the more examples, the students will understand the concepts. That is called as solution for the underfitting. Training is not proper. Underfitting means training only not proper. Training is not proper means give the more examples. More examples means more records. Is that clear? 90% of the cases, not 90, 95, 99. 99% of the cases, 99% cases will have this one. In 1% of the case, we'll have this one in real life. Okay. So 99% of the cases will have the overfitting problem only. The machine, whatever the data you provide, it will try to understand that one. It will by heart that one simply. Right? 99% of the cases, the machine will understand the data. Whatever the data you provide, it will identify the relation according to that. If you give worst data, worst relation. Good data, good relation. Whatever the data you provide, it will identify the relation. Relation is common. Whether that is a good one or a bad one, that is secondary. Getting the relation is perfect. It will try to get the maximum relation. And it will lead to the overfitting problem. And many algorithms, advanced machine learning algorithms, whatever the advanced machine learning algorithms we are having, all the advanced machine learning algorithms, all the advanced ML algorithms, all the advanced ML algorithms has overfitting problem. For all of them, it is having the overfitting problem. Every advanced algorithm, you select anything of your choice. The solution for all these advanced algorithms is hyperparameter tuning. In all the advanced algorithms, we are going to do the without hyperparameter tuning, there is no one algorithm also. We have to apply hyperparameter tuning. That is the reason in yesterday's class, I have told you very clearly, hyperparameter tuning is playing a very important role. Understand very clearly, slowly. Okay. Hyperparameter tuning, already I have told you. What is meant by hyperparameter tuning? Model parameter you are going to tune. Means you are going to try with the different values. After trying for different values, which value suits the best, that one we are going to finalize. That is called as hyperparameter tuning, which we have discussed in the last class. If you have missed the last class, try to take the recording and understand that hyperparameter tuning very clearly. Because without hyperparameter tuning, it is waste to sit in the further class. Even today's class also, you will not understand without hyperparameter tuning. Okay. In regularization also, hyperparameter tuning is going to play a very important role. Right? Next. So let's discuss now regularization. Now, what is meant by regularization and how it is going to reduce the overfitting problem? Let us see this. So next, regularization. Regularization, where we are having in terms of, it will identify and it will give the solution for few common issues. That is minimizing the model complexity. What is the problem in polynomial regression? As the degree increases, complexity increases. I ask you to write that statement. As the degree increases, the complexity increases. As the complexity increases, overfitting problem it is going to lead. Okay, right? As the model complexity increases, overfitting problem you are going to see. So you are going to penalize the loss function. Now here, the most important point again comes into picture. Again, you have to write in the notes. So many important points are coming. Loss function and cost function. Loss function and cost function. Everything is equally important, guys. Don't miss. If you don't understand, ask. These are all equally important for all the machine learning algorithms. First, let us start with loss function. Loss function means nothing but error of each record is called as loss function. Error of each record. Meaning is you are going to have the original data y. Okay, in your notes you draw the this box. Okay, later once it is clear you draw. Okay, I can't draw with in the notepad now, so I'm using my pen. So I'm having the original data y. I assume that 5 records are there. 1, 2, 3, 4, 5. 5 records are there. And using your model, you are going to predict the y hat. Using your model, you are going to predict. Model.predict on data. Whatever the data you are giving, it is going to predict the values. These are the predicted values. For each data, you are going to calculate the y minus y hat. First, you have to calculate y minus y hat. After that, y minus y hat whole square. So if you calculate y minus y hat for each record, each record, whatever the error is there, this is called as loss function. Simply to say, loss function is equal to y minus y hat. It is called as loss function. Now coming to the next one is called as cost function. Now cost function. Next one is cost function. Cost function is overall error. Overall error is called as cost function. What is meant by overall error? So you have calculated each error. After that, you are calculating the y minus y hat whole square for each of them. For each record, you are calculating. Overall, you are going to calculate the summation of y minus y hat whole square divided by n, which is nothing but mean of the error. You are applying the mean. For overall data, you are applying the mean. Just this mean, whatever the mean square error we are having, this MSC is called as cost function. RMSC, if you calculate RMSC, this is also cost function because you are calculating for overall. SSC, if you take SSC, summation of y minus y hat whole square, this is also cost function because this summation means overall, not for individual record, overall, all the records you are going to add. If you add multiple records, the errors, if you add, then it is called as cost function. If you take for only single record, it is called as loss function. Single record is called as loss function. Overall, it is called as cost function. Is that clear? Loss function and cost function. If you are taking on one record, then it is called as loss function. If you are taking overall all the records, whatever the records are there, then it is called as cost function. Now the question is, sir, why I have to consider overall? Why? For example, in this class, I am conducting one exam. Okay. And the students has written the exam and they have got the marks. Now, if I want to check the students' marks, and for example, Naresh sir is asking me the question, some X person, third person, and he is asking, sir, how the class performance is there? How the class, now I should say about individual student or I should say about overall students? Whenever I want to say about overall, whenever the word comes with respect to overall, that is nothing but mean. Whenever you are discussing about overall, then it is called as mean. For example, you have taken the multiple test. Till now, how many tests, how many Saturdays you have taken the test? Approximately 3 to 4. Okay. And in the future, you are going to take 10. Okay. Furtherly, 10 weeks will be there and you are going to take 10 more tests. Now, these are 4 plus 10, 14 tests. And I want to see your performance, miss. Overall performance I want, miss. Then what I have to consider? Average only, right? Average performance only I have to consider, right? I can't take with one each of them separately. I can't take, right? Average performance only I'm going to consider. Whenever there is a overall records, when you want with respect to overall, then we have to take the average automatically. Average you have to take, means first you have to do the sum. Sum divided by total number of data points. So whenever there is multiple records, automatically in your brain you have to get is average. If you are focusing on one record only, for example, if Naresh sir asked me, sir, how one of the student name is Suresh. In your class, one student name is called as Suresh. How this Suresh is performing, miss? Then I'm going to say about him only. Sir, he has got a minimum marks of this one and he has got a maximum marks of this one and something I'm going to say. Then I'm not going to discuss with respect to average. And that too, this Suresh, I have conducted only one exam. I have not even conducted multiple exams. Now tell me what I have to tell. Can I do the average? If I do the average also, that is the same answer. If I do mean also, that is the same answer. If I apply mode also, that is the same answer. If I apply minimum also, that is the one mark only. This is the only 1 mark. For example, he has got 80 out of 100. Only one exam was conducted. What is the average marks? 80. What is the median marks? 80. What is the mode marks? 80. What is the minimum marks? 80. What is the maximum marks? 80. What is the range? 80. Anything is same only, na? If you are having one more record along with this, average mark will come, mode marks will come, median marks will come, so many things will come. At least 2 records should be there. Minimum to minimum. That is the reason we know that we have to consider minimum 2 values. For one, we should not apply the analysis. That is n-1 degrees of freedom, which we have applied on the sample variance and sample standard deviation. Minimum to minimum 2 records should be there. We can't apply for one record that one. That logic we can't apply on a single record. Right? Now, here the cost function, whatever the cost function is there, cost function means overall error, loss function means error of each record. Error of each record, that is y minus y hat. This is also error of single record. Modulus of y minus y hat. This is also single record. Y minus y hat whole square. This is also single record. Now, whenever you use the summation word, then it is overall. That is y minus y hat or sigma of y minus y hat, modulus of this one, sigma of y minus y hat whole square. When you are using that sigma, then only it is overall. Means you are considering multiple and n. As we all know, this we should not consider, this we should not consider. Only this one we have to consider. So always the cost function is going to be mean square error for regression problems. Is that clear? Now in the regularization, we are going to minimize the loss function. Loss function means for every record, we are trying to reduce the error. If we start reducing for each record the error, automatically overall error also will be reduced. We are trying to reduce the loss function, but penalizing means penalty, means reducing. Penalizing means nothing but reducing. Simple word, reducing. You are penalizing the loss function, means you are simply reducing the overfitting problem by adding the bias. By adding the bias, you are trying to reduce the variance. As to reduce the model overfitting and variance requires some additional bias. You are adding some more bias. Now, here we are having 3 types of regularization. One is called as L1 regularization. Second one is called as L2 regularization. Third one is called as L1 plus L2 regularization. A combination of L1 and L2. Don't say L3. It is not L3. It is combination of L1 and L2. Okay. So combining L1 and L2, it is called as third one. So L1 regression is also called as lasso regression. L1 regression or lasso regression. L2 regression is also called as ridge regression. The combination of L1 and L2 is called as elastic net regression. So you can write in the notes. L1 regression, which is equal to lasso. L2 regression, which is equal to ridge. A combination of L1 and L2 is called as elastic net. Once again, I'm saying this is reducing the overfitting, and most of the advanced algorithms are having the overfitting problem. And for that, we have to apply the regression or hyperparameter tuning. In the future classes, multiple times we are going to get this regression concept. At that time, I'm not going to explain once again. Please focus very clearly. This is going to be repeated for multiple times. They are connected to each other multiple times. It is going to have. Okay. Whenever there is a word called as L1, automatically it is applying the L1 regression, which is of lasso. L2 regression, ridge. Combination of L1 and L2 means elastic net. Now, which one we have to apply? L1 or L2 or L1 and L2 or which one we have to apply? We have to apply 3 of them. For the given data set, we have to apply 3 of them. So 3 of them means 3 times doing the same model, repeating the same thing means, I already told you, whenever you want to repeat the same code for multiple times by changing only one parameter, apply the for loop. Just apply the for loop. In the for loop, regression is equal to first time you take L1, regression is equal to L2, regression is equal to combination of L1 and L2. Just apply the for loop. Repeat the code. Whenever you want to repeat the code, apply the for loop. And that too, if you observe in the linear regression notes, whatever the coding part we have discussed, in the notes, I have shown you separate cells. In the each cell, we have discussed modeling separately, prediction separately, and evaluation separately I have written. In the real life, you don't need to write that many cells. Everything I can copy in a single cell only. For my explanation, I'm writing in the different cells. In the company, you are not going to explain to anyone. You are not going to keep those many headings. Separately modeling, separately model selection. You are not going to keep any headings. Are you going to explain to anyone? Everything you are going to copy into a single cell only. You are not going to explain to anyone. Right? I am explaining for you. So I have to show you what is meant by polynomial features. So I have separated the polynomial features in the last class in a separate cell. Linear regression modeling, I have separated in a single cell. I have separated the prediction, what is meant by prediction, and what is meant by evaluation, what is meant by model selection. Separately, I have explained for you. For explanation purpose, I have taken in a different cells. In the real life, to whom I am explaining, to whom I have to explain all these things. If I copy everything in a single cell and if I see final answer, who will stop me? I require only the final answer. Whether my model is a good model or bad model, I want to conclude in that one. Whether if I write in 20 cells, whether if I write in a single cell, the answer is same only. Right? Instead of copying in multiple cells, I will do the copy paste into a single cell. Right? Now coming to this one, lasso, ridge, and elastic net. Now first one, let's start with the lasso. Okay, lasso, ridge. These regression methods do have a cost. They introduce a additional hyperparameter that need to be tuned. Okay. Now, what is meant by regression? So we actually cover the L2 first. First, we'll start with L2, that is ridge regression. Why? Because easy to understand. The reason is easier to understand. L2, ridge regression is easy when compared to lasso. Now, ridge regression is having the advantage to avoid the overfitting. Not only ridge, lasso also same. Our ultimate model is the one that could generalize the patterns, means works based on the training and also test data. It should work on the both trained data and test data. It should not either only work on the trained data. It should neither only work on the test data. It should work on the both of them. Properly, it has to work on the both of them. Overfitting occurs when trained model performs well. Your trained model is performing very well and performs poorly on the testing data. Then only you'll get the overfitting problem. Train accuracy is very high, test accuracy is low. Now, Ridge regression works by applying a penalizing term. It is going to add one penalizing term, which is penalty term. We are going to add a penalty term in order to overcome the overfitting problem. Now, if you observe here, I'm having these three data points. These are the three data points which are used for training. Clearly focus. Forget about this one. Let us, this data is only not there. Forget, this data is not there. You are having only this data set. You are having only three data points in your scatter plot. Only three data points. And you want to identify the best line which suits for these three data points. Now, what you are going to do? Simply, you are going to select the least sum of the squares of errors. That is, sum of the squares of should be minimum in order to get the best fit line. Means this line is going to pass through the three training data points. Now, what is the error will be there? If the line is passing to the original data, then what is the error? 0. Nothing will be there. The sum of the squares of errors is going to be 0 because this is the original y, this is the predicted y. This is the original y, this is the predicted y. This is the original y, this is the predicted y. Original y and predicted y both are same. Then automatically the error is going to be 0. Y minus y hat is equal to 0. There will be no difference. Now, here, if you go with the, now, this is test data. Now, for test data, you have got, what is the error? 0. Test error, sorry, train error. Train error is equal to 0 because the line is passing into the training data points. The error is equal to 0. Train error is equal to 0. Now, if you observe this, for testing data, the sum of the errors is high, which is having the high variance. Okay, high variance. High variance means high test error. Test error is very high. Now, variance means there is a difference in the fit between the training data set and testing data set because this is the original y. But predicted y is this one because your line is this one. Whatever you are having, this is the predicted values. All your predicted values will be on the line only. This is called as predicted line. I already told you what is meant by predicted line and what is meant by normal line. So this predicted line, this is the original y, this is the predicted y. Now you are having the error between them. For each data point, you are having some error. For each and every data point, you are having the error. So now in this case, if you observe clearly, train error is equal to 0, but test error is very high. Because, sir, what's wrong in that, sir? The data was given like that. The data was given like that. So you have given 3 data points and the data, I'm passing the line into that. And it is ignoring what is there in the test data. It is forgetting the test data and you are going to test on unknown data. It is forgetting. Now what I'm going to do for this, I'm slightly reducing this one. Now the test accuracy is going to be decreased. Means error will be decreased and train error will be increased. Right? Now ridge regressions works by attempting increasing in the bias. Increasing in the bias. What I have told you bias means train error. So now it is trying to increase the train error. It is increasing. What it is increasing? Train error it is increasing. Generally we have to decrease, but it will increase. Train error it is increasing and it will reduce the test error. Increase this side and decrease another side so that both of them will be level. See, simple logic. You might be get confused. So I'm explaining with a very simple logic once again. Train error, train accuracy, test accuracy. I'll explain first with respect to accuracy. Later I will explain with the errors also. Same thing, opposite to that only. Now assume that I'm having train accuracy 100%. Accuracy 100%. Test accuracy 70%. Which is a overfitted problem. Now what I'm going to do here, I'm trying to reduce this one in such a way, I'm bringing this one to 90. I'm reducing it to 90. And here I'm increasing this one to 85 or 86, something like this. One side I'm decreasing and one side I'm increasing in order to balance. Now, you might ask me the question, sir, here 86, okay, sir, this is nice. Why you're decreasing the other side? Without decreasing, if you get this one by keeping 186 directly, if you get miss, that is the best only. That is better only. Okay. If you get with 100% and 96 directly miss, it is okay. If you get 100 and 100 means it is extraordinary. But we are not able to get like that. So what we are going to do, this is one of the method. What is the one of the method means trying to reduce this one. We are trying to reduce this one to 85 or something. And we are trying to increase this one to 85 another way. One side we are decreasing and one side we are increasing. In this algorithm, it is going to attempt in this way by reducing on one side and by increasing on another side. Is that clear, guys? So I also your common doubt. Most of the students commonly they'll ask common question is, sir, train accuracy is decreasing now. Yes, train accuracy is decreasing, but test accuracy is increasing, right? So, for example, train accuracy are not decreasing. Assume that you are not decreasing. When compared to this one, this is best or this is best, miss? If this is best or this is best, miss, without decreasing the train accuracy, can't we increase directly the test accuracy? Is that possible? That is not possible using here. This algorithm will not support in that way. That is possible for another algorithm. That is the question has got for a scientist. Hey, can't we decrease in that way? He has invented one algorithm. Before to that, this scientist invented, for example, this scientist has invented in the year of 1998 a new algorithm. This was invented before itself in the 1990. Assume. Example only I'm saying this. Not years are not important for me. Okay, here we are not conducting any GK test, right? So just in order to by reducing the train accuracy, we are increasing the test accuracy. Is called as regularization. This is one of the concept. Is that clear, guys? So from where they have got this idea is very simple. We are having the weighing machine, right? That too, in terms of not electronic weighing machine, the old one. Okay, the old one, which is balancer. On one side, we'll have the stones, and other side they'll keep whatever the product we required. Right now, here, one side we are having 1 kg stone. The product, for example, I'm asking 1 kg sugar. Other side, I'm having only 400 grams. It will not be balanced, right? The balancer, the heights will be, the difference between them will be like this. The weight will be down and the product will be on the top, something like this. Now, what we are going to do? We are going to add something on this. Slowly, we are going to increase this one and trying to bring this 1 kg stone to upside, and the product we are trying to bring downside, and we are balancing both of them. This will be like this. Slowly, this will be reduced. At the same time, it will also be increased. And finally, both will be same on the same height. Have you observed balancer? From our childhood onwards, we are seeing, right? Now, where does electronic machine has come? But same thing. Just you are adding the one side and you are balancing that one. Simple. So this adding of that product is called as here penalty term. Just you are adding the penalty term. So here the ridge regression is going to work by adding a penalty term. What is our linear regression means? Linear regression. Our linear regression says that sum of the squares of error should be minimum. SSE should be minimum. That is nothing but sigma of y minus y hat whole square should be minimum. This is the requirement of linear regression. Now, what is ridge regression says means not only SSC, along with the SSC, one penalty term. There will be one penalty term, and along with this penalty term, it should be minimum. Overall, it should be minimum. Along with this penalty also should be added. Penalty term also should be added. Overall, it should be minimum. What is that penalty term? SSC we know, that is y minus y hat whole square. This is SSC. Now, what is penalty term? Penalty term is nothing but alpha into slope square. Whatever the slope is, the slope square. That is the penalty term. And this should be minimum. By adding this penalty term, we are reducing the overfitting problem. Right? Now, means to be more precise, let me write like this, X and Y. Now I'm having only X records and Y records. Now what generally I will do, I'll identify D by, what is this equation I'm going to create? I'm going to take the equation Y hat is equal to beta naught plus beta 1 X. And I'm trying to get the minimum sum of the squares of errors. For getting the minimum sum of the squares of errors, D by dx of sum of the squares of errors, that is whole square, this one, which is nothing but D by dx of summation of y minus beta naught minus beta 1 x whole square. And from that, we have calculated what is the beta naught and what is the beta 1 value. This is the one which we have applied the linear regression. Now, the same thing in the ridge regression. What happens in the case of ridge regression? This is in the linear regression. D by dx of sigma of y minus y hat whole square. In the ridge regression, what happens means you are trying to minimize the y minus y hat whole square plus alpha into beta square. This should be minimum. That is beta means slope only. That is beta 1. That is sigma of y minus y hat. That is y minus beta naught minus beta 1 x whole square plus alpha into beta 1 whole square. This should be minimum. You have to identify the beta 1 and beta naught in such a way it should be minimum. Earlier, this should be, you have identified the beta naught and beta 1. For this one should be minimum. Now this time you are identifying this one should be minimum. Got the point? That is the only difference between both of them. Now, sir, here let us assume I'm having one more for multiple linear regression, that is x1 and x2. Then we'll have beta 1, beta 2 and beta naught. Then which beta I have to consider? In that case, summation of beta square. That is beta 1 square plus beta 2 square. Alpha into beta 1 square plus alpha into beta 2 square. Okay. Beta 1 square and beta 2 square. Both of them you have to consider. Alpha into slope square. Simply to say slope square. So the penalty term, whatever the penalty term is there, the penalty term is equal to alpha into slope square. Now what is meant by alpha? What is meant by alpha? Slope means I know in the equation, whatever the beta along with that variable, whatever the quotient is there, that is called as slope. That is okay. What is meant by alpha? Alpha is called as learning rate. It is not a fixed value. We have to do the hyperparameter tuning for the alpha. Alpha is a hyperparameter value. As I have told you earlier in the back, it introduces a additional hyperparameter that needs to be tuned. You are going to get introduced. Introduced means alpha into slope square, out of which this is the parameter which is getting introduced, which to be tuned. with 0.4 means everything 0.41. Everything should be on the same factor. One slope you can't decrease by this much, and one slope you can't decrease with another way. If you here, all the quotient should be shrunk by the same factor, right? And doesn't necessarily eliminate the quotients. This is one of the most important one. Doesn't eliminates the coefficients. What is the meaning of this? Means by trunking that one, while doing that one, it will give the beta value. The beta is going to be very, very, very minimal. If that particular quotient is not important, if that particular variable is not important, it will give the beta value. Whatever the quotient value is there, it will give very minimal value. The quotient is going to be very minimum if the variable is not important. For example, let's take like this: TV, radio, newspaper. Now, newspaper column is not important for me, assume. Then automatically the beta 3 is equal to 0.001 something. I will get like this. What is the meaning of this one? 0.0001 means for every $1,000 if you invest also, you'll get only 0.01 only units. For getting 1 unit, you have to have with respect to at least how much amount you have to invest in order to get $1. $10,000 you have to invest. Then only you'll get $1. Because here this is equal to 10 into, sorry, not even 10, $1 lakh. $1 lakh, 10 to the power of minus 5. So 10 to the power of minus 5 means you have to multiply with 10 to the power of 5. 10 to the power of 5 means 1 lakh. If you multiply with $1 lakh, for every $1 lakh you invest, then only you'll get 1 unit sale in the product. Means anyone will invest in newspaper. For getting one unit sale, what is the profit I will get, and have to invest $1 lakh for that one means. Then for one product, I have to invest $1 lakh means how much profit I have to get for that one product, right? So simply the quotient value, if the quotient is very, very low, means automatically it indicates that it is not an important variable. Here in the ridge regression, it is going to give whichever the unimportant variables are there, it will give the beta value as the minimum. As the beta is very, very low, the meaning is it is not important. Now we are having the, as alpha increases, the slope of the regression line decreases and becomes more horizontal. If you increase alpha, if you start increasing, if you try, somewhere it will become the horizontal line. Then no linear regression only will be applicable. No regression only will be applicable. Average line will be the best fit line. Regression concept only completely becomes zero. So we should not have in that way. So between that, we have to do the tuning. In that, we have to do the tuning, right? If you increase, as the alpha increases, okay, everything is okay like this means suddenly it will decrease and you'll get the horizontal line. Okay. Now coming to the lasso. Lasso also same as ridge regression. Lasso also same to ridge regression. Now, only difference is penalty term is alpha into modulus of slope. Instead of considering slope square, you have to take modulus of slope. Simple. That is the only difference. Penalty term is the only difference. Remaining everything is same. Okay, everything is same. Now, the effect of alpha on lasso regression is similar to ridge regression. As you increase the alpha value in this case also, it is going to be more horizontal and average line will be the best fit line. Regression only will become to zero, right? Now, here the most important point is there, which you have to write in the notes. Lasso regression helps to reduce the overfitting and it is also useful for the future selection. This is the important word. Okay. Before writing, just understand. Later you can write. Okay. Important point means immediately you'll start writing now. First understand what is that important point. First, let me complete that important point. Okay. Lasso regression is useful for future selection. How? Means very important. The point is not, wait, don't write. If I'm saying important point means first you are opening the notes and you are writing off. Just let me explain. Okay. If you are having the multiple variables, x1, x2, x3, x4, x5, and y, you are having variables like this, out of which this is the unimportant variable. X3 is unimportant. Now, if x3 is unimportant, how we can identify in the ridge regression? In the ridge regression, how we can identify that one is the beta value will be very low. The beta value is very low in the ridge regression. In lasso regression, if it is unimportant variable, how we can identify in lasso regression, the beta value is directly zero. Directly zero only. It will say directly zero. It is not useful. Simply it will say zero. If whatever the output beta value is getting zero, that is a unimportant variable, and simply we have to delete that one. This is one of the future selection technique. This is one of the future selection technique to identify the important features in our data set. This is the lasso regression we are going to use. So in the after applying the lasso regression, we are going to check the quotient values. Whichever the quotient, for which variable the quotient is going to be zero, that variable is unimportant variable. Lasso regression can be useful if you are having several independent variables that are useless. For useless independent variables, if you feel that useless independent variables are more, then apply the lasso. For all the useless independent variables, it will become to the zero. Ridge regression can reduce the slope close to zero, but not exactly zero. It will bring to close to zero, means 0.00001, like this it will bring. But whereas lasso, directly it will say that it is equal to zero only. But lasso can reduce the slope exactly equal to zero. That is the advantage of lasso. So lasso regression is used for future selection. Lasso regression is used for future selection. So lasso regressions adds a penalty equal to absolute value of the magnitude. It will add the absolute value of the magnitude of the coefficients. And if you observe the difference, this is linear regression, ridge regression, and lasso regression. Linear regression, sum of the squares of error should be minimum. In lasso, sum of the squares plus alpha into modulus of slope should be minimum. In ridge, alpha into slope square should be minimum. Along with this penalty, it should be minimum. Right? For example, let me explain in a very simple way. In this class, student is there. One student is there. Which student is the topper? I am having multiple students. Multiple students are there. And I want to identify which student is the topper, means which student is having less error is called as topper. Less error means high accuracy, high marks, obviously. So a student with less error, I want to identify. Now I'm having in this class, 3 to 4 students are doing very good. Student number 1, student number 2, student number 3, student number 4. These 4 students are doing very good in the class. They are very good. 4 students are very good. Now I want to identify out of these 4 students, 1 student. Now for that, what I'm going to do, instead of testing them directly, I'm going to assign the bad student 1, bad student 2, bad student 3, bad student 4. In the class, these are very good students, means in the class, bad students also will be there, right? In a class, toppers will be there. At the same time, bad students also will be there. I'll identify the best 4 top worst students. These are the top bad students, means in the subject wise, from the subject wise, not their character wise, only subject wise, means who are having the low marks. These are the 4 students who are having very high marks. Now what I'm going to do, I'm going to assign for each one top student, one bad student also. For each one top student, I'm going to assign one bad student. Now, after assigning this one, now they are group. These 2 students are one group. These students are one group. This one is one group. This is one group. Now for this, I'm going to conduct the test. Now the test, which group is best, I'm going to identify. Now, if this student is very clever, automatically he will guide this bad student also into a next range. Now, in one shot, 2 birds. One student, this bad student also will have more knowledge. And while explaining to him, he will have still more knowledge. Obviously, this student is very good at learning, means he'll have multiple questions now. Every minute question he'll ask. When he is asking every minute question, he will learn more things, obviously. Right? This is one way. Not the best. Might be best, may not be best, but one way. This one way we'll try. What is our ultimate goal? What is our ultimate goal? Our ultimate goal is to get the best student in this class, only one best student. To get that one, I can conduct directly test only to the students. I can conduct like this also. This is one more way. This is my idea. Assume. This is my idea. If it is working, miss, works. If it is not working, miss, it is a waste idea, and I'll try with one more idea. What is our ultimate goal? It is finally, I want the one best student in the class, only one. For identifying this one, there are multiple ways are there. Out of this is one of the way. I'm not saying this is the only the best way. This is one of the way. If it gives the best result, miss, okay. If it is not giving best result, miss, I'll try in another way. Next way, different way like this. Okay. This was done in my life. It was done. Okay. In my life, while studying intermediate in one college, they have done like this. My principal, I mean, my college trainer, whoever is there, he has done this logic. Okay. He has identified the toppers. He has identified the weakers in the last session. Toppers in the first session, weakers in the last session. He has combined both of them. And finally, these 4 students are the state rank holders. In that, I am also one in my intermediate. Right? Simple logic he has applied. At the time, for explaining these people, we used to find shortcut for explaining for them. Because next day, my principal used to test for batch wise. He used to not to test individual wise. And who has done the better performance, he used to give outing. Otherwise, we used to not get outing in our hostel. For getting outing and to go outside, this is the only option for us. He has played the game in that way. At the time, it was happened, continued. We are the part of that. Right? So, just the same logic here, instead of considering a single one is linear regression. Instead of single separately, I want a combination of along with this penalty. A linear regression along with the penalty should be minimum. That is the concept of this one. Why only focusing on this one? Along with this, you focus on this one also. Automatically identify this one is best, or this one is best. You try all of them. For a given model, finally, I want a better accuracy on the test data at the same time on trained data. Whatever the ways are there, you try all the ways. Finally, I want my students to get successful and they want to get the placements. Now, for that, whatever the different options are there, I will try. In that, one of the option is every weekend conduct the test. That is one of the idea which I have got for your batch. That was not conducted for previous batches, only for your batch. For previous batches, that idea I have got at the end. For your batch, I have got the idea at the starting only. Why we can't conduct in this way every week? Let us try and implement. And if you see here, in this Naresh IT, there will be mentors. In the mentors, multiple mentors are there. If you observe all the mentors are with other batch trainers only. With my batch, not even one student is there as the mentor. Okay. There is one student and he has even got today the placement and he has. Right? Why? What is the reason? When compared to other batches, in other batches, they are not having with respect to placements. At least they are trying as a mentors. In my batch, the students are not ready to join as a mentor only. If you give the opportunity also, they are not ready because they are having the confidence that they'll get a better opportunity than mentor. They are feeling in that way. I have given the requirement, Naresh IT, we required data science mentors. Not even one student has applied. Naresh sir has called me. SRK, have you discussed with your students? Sir, I have discussed, sir. But we are not getting the students. See, they are not applying. Means what I have to do, sir? They are not applying. Why they'll not apply? Why they'll not apply? Because they are having the confidence that they'll get a better opportunity than the mentor. Whatever the mentor, why to go with mentor? Let us go with the low scale only. Data science also okay, and they're trying. For that type of confidence, they have to get that one. Miss First, they have to feel that they are having a good subject with them. How to feel that they are having a good subject means they have to check the interview questions in the Google. When they see the interview questions on the Google, all the questions, answers they are familiar, automatically confidence will be there, right? After this class, type in interview. After this class, type in the Google. I'm not saying any web page. I'm saying overall Google. Select any web page of your choice. Any web page. For me, no problem. That type in the Google, interview questions on linear regression. Just type in the Google, interview questions on linear regression for a data scientist. Just type in this in the Google. Whatever the pages you get, open each and every page of your choice and tell me whether we have covered the questions or not in the tomorrow's class. Right? Every question we have covered. And 99.99, you will answer most of the questions if you have practiced earlier. So by seeing that one, automatically the students also will get the confidence. Oh, these are the interview questions and this is the answers. Okay, this is common. And that too, we have done mathematically step-by-step procedure. Right? Is that clear? This is lasso and reach. And now we are going to apply the coding part on the lasso and reach, where alpha, this alpha is a unknown value, where we have to do the hyperparameter tuning. That we are going to see in the tomorrow's class. In the tomorrow's class, we'll see the coding part of this one. Is that clear, guys? And along with the elastic net also, the theoretical part of elastic net. Elastic net is nothing but combination of L1 and L2. Combine both of them. In the penalty term, combine both of them is called as elastic net. SSC is common, plus alpha into 1 minus lambda into sigma beta square. Okay, don't observe this one. Don't see this one. Don't get confused. Simply, it is nothing but sigma into beta square. 1 minus lambda into sigma beta square. That is nothing but, it is called as ridge regression. Sigma into modulus of beta. What is meant by this one? Which is nothing but lasso. Now 1 minus lambda and here lambda. What is the meaning of that? Miss? Here the lambda is the amount of selection you are going to do for lasso and reach. This is called as ratio, L1 ratio. The lambda is called as L1 ratio. Means amount of L1 divided by amount of L2 you are going to select. So for example, you are taking the this one as 0.6. Means 60% you want the L1, 40% you want the reach. Both of them you are taking now. L1 and L2, a combination of L1 and L2. 60% of L1, that is, this is 0.6. If this is 0.6, then automatically this is 0.4, 40%. If this is 0.7, then what is this one? 0.3. If this is 0.8, then what is this? 0.2. If this is 1, then what is this? 0. If lambda is equal to 1, then it is equal to lasso regression. If lambda is equal to 0, then what is then? It is ridge regression. How much percentage of lambda, how much percentage of lasso, how much percentage of ridge you are going to combine is called as lambda. Is that clear? So lambda is equal to 0 means which is equal to ridge regression. If lambda is equal to 1 means which is equal to lasso regression. How much combiningly you are going to combine, how much percentage you are combining the lasso with ridge is called as elastic net. I am going to consider 10% of lasso, 90% ridge, 20% lasso, 80% ridge, 50% lasso, 50% ridge. This lambda also not fixed value. This is also hyperparameter tuning. Lambda is hyperparameter tuning, alpha is hyperparameter tuning. Sir, for lambda of hyperparameter tuning means for loop. For alpha parameter tuning means for loop. Then what is that one? Nested for loop. First, you are going to take alpha and lambda for different lambda values. For fixed alpha, you are trying for different lambda values. Once this is completed, you are changing the alpha value like this. Nested for loop you are going to apply. That we'll see in the tomorrow's class. The coding part I'll explain in the tomorrow's class. Is that clear? Any questions? If you have any questions, you can ask. If you have any questions, you can ask. Paragraphs and theory, it is like somewhat Korean. Anyone has felt like that? Without learning the linear regression, without attending the linear regression, automatically it will be like this. Whoever has attended the linear regression, whoever has understand the sum of the squares of errors as minimum. For any data, sum of the squares of errors should be minimum. Now, instead of focusing only on the sum of the squares of errors along with the penalty should be minimum. Just add the penalty. In one word, you have to conclude today's class means adding the penalty to the linear regression. Adding penalty to linear regression is called as regression. To explain this one sentence, 1.5 hours I have taken. Right? Is that clear, guys? Just adding the penalty term to the linear regression is called as regression. Done. So that is the end of the session, and we'll continue in the tomorrow's class.